All right, this is Honors Algebra 2 Pre-Calculus. We're doing section 1.7 in Algebra 2, which is Intro to Solving Inequalities. So on page 54 of your textbook, what you're going to find is that there's a blue box with the properties of inequality, similar to how in 1.6 you had a blue box with properties of equality. Rather than write that box here, and you're welcome to look at it on page 54 in your textbook, but rather than write that, what's easier is instead of pretending that these are completely different situations, it's easier to look at the properties we already know about equalities, because most of us are pretty comfortable with equations, and look instead at what properties are different for inequalities, right? And it turns out that there's really only two things that we have to worry about when solving inequalities. So let's talk first. We did, when we talked about equations and expressions and inequalities in a previous section, we talked about what an inequality is, right? So there's essentially four different symbols that you'll see in the middle of an inequality, okay? So here are the symbols that we're looking at, okay? So I'm actually going to use A and B. So A is less than B. That's the way we would read this. We would read this as A is less than B, okay? And what that would look like is that if we were to put this somewhere on a number line, it would mean that A is farther to the left than B, right? I'm going to show you how to graph these in a minute, actually. So the next option is A is less than or equal to B, right? So that's A is less than, or, so that was less than only, so less than or equal to B, okay? We have A is greater than B, right? So these are sort of like directional arrows, and if it has an equal to, it has a line underneath. So this is A is greater than B. So that's just strictly greater than, right? And then this would be A is greater than or equal to B. So A is greater than or equal to. And I think most of us already know this from our background stuff with math, but it's worth making sure we're aware of the symbols. So a couple things about an inequality, right? We've talked about how in an equation we had a left-hand side and a right-hand side, and that's true here as well, right? But remember that when we talked about equations, right? So when I talked about an equation, if I had A equals B, I could flip this whole thing and say that it was the same as B equals A, and that was just fine. The problem with an inequality is that if I flip the entire thing, right? So if I have A is smaller than B, that means that A is supposed to be a smaller number than B, right? If I flip it, I need to keep in mind that I'm flipping the entire statement, so it would now say B is greater than A. So it would flip both the letters, but also the symbol in the middle, because the symbol has a direction. One easy way to think about that is it's almost like you were flipping this symbol too. It's just that since the symbol is just two horizontal lines or two horizontal segments, it still looks exactly the same. Whereas when you flip this symbol, it looks different, right? So just a thing to keep in mind. So there's a bunch of different ways that people memorize this, right? One way to do it is if you hold your hand in front of you, right? Your left hand makes an L, right? So L is for less than, right? And you can think about it this way. Let's see how this is kind of an L. L is for less than, right? It's another way people sometimes practice if they're bad at left and right. So again, one way to think about it is L is for less than. The other way to think about it is that if you made this like a fish or a Pac-Man, it's eating the bigger number. So A is less than B means that B is the big number here, right? Whereas A is greater than B means A is the bigger number, and the Pac-Man would eat the bigger number. Whichever way is easier for you to think about it is totally fine. So when we solve inequalities, we're really going to do exactly the same thing we did for equations, except we're going to keep these extra rules in mind that I'm going to leave here. And we're not really going to do much with rule number 2 until we get to talking about absolute values, which is in 1.8. So let's walk through some basics with inequalities. So the other thing we're going to talk about is how it's actually easier sometimes to graph solutions to inequalities, and we'll talk about what that looks like. And then I'm going to teach you a notation that your textbook actually doesn't. I'm going to teach you a notation called parenthetical notation because it's something that you're going to find is much more useful as you move forward in mathematics, although it's not a notation that your textbook currently uses, right? So your textbook is aimed specifically at Algebra 2, and it's a high school level textbook. I try to throw in stuff that's a little more collegiate level whenever I can. All right, so we're going to go ahead and steal example 1 from the book, because every once in a while I'm lazy and I go with the book example, and that's fine. So example 1 in the book asks you to solve 4x minus 5 is greater than or equal to 13, okay? And then we'll put a P1, which is the problem that occurs right below that in the book, which will be negative 4 is less than, 7 minus 3x. Now, what we're going to do here is we're going to solve. So first thing we're going to do is solve, right? Second thing we're going to do is we're going to talk about how to graph the answer. And then the third thing we're going to do is we're going to give the answer in parenthetical form, which is the thing I'm going to teach you. That's not how you spell any of those words. Parenthetical form, which is the thing I'm going to teach you that your textbook doesn't actually emphasize, but I think is super duper important for you to learn a long haul. So that's what we're going to do for both of these problems. So let's walk through example 1 first. So just like solving equations, if I only have the 1 power of my variable, I only have a 4x, that's it, I'm going to use SADMAP. So I'm going to start with subtraction or addition, right? So I'm going to start by adding 5 to both sides. Now that's not an issue for an inequality, right? I can add 5 to both sides. That doesn't change the direction of the inequality. If this side is bigger than this side and I add 5 to both sides, that's still going to be true that the left-hand side is bigger than the right-hand side. Then I'm going to do my division and multiplication. Because I'm dividing by something that's positive, I don't change the direction of the sign. So I'm going to get x is greater than or equal to 9/2, or if you prefer, you could write it as x is greater than or equal to 4.5. It doesn't matter to me if you're a decimal or a fraction person, it's entirely up to you. I'm personally a bit more of a fraction person, but I don't care. Okay, so this answer's great. This is also okay. Same answer. I'm just going to pick this one, okay? So first thing I did was solve. 1, solve. Second thing I'm going to do is I'm going to graph this. Now, when you were asked to graph things on number lines as a kid, your teacher might have had a ton of rules. Like, you have to start at 0 and the scale has to go by 1. That's all super duper crazy. Here's what I need from a number line for you, okay? Because remember, at this point in math, I'm not testing your ability to do really simple skills. I'm testing your ability to solve a problem, and I don't need to see that you can put little hash marks on a number line. I don't care. So here's what I suggest. You put the number that you want at the center of your number line, so 9/2, right? And then you put literally any other number in the correct spot. So since this is 4.5, I could put a 10 right here. Why do I need you to put a second number? I need you to put a second number because I need to understand that your number line goes in the correct direction. I need you to understand that this is where the bigger numbers are, right? This is where the smaller numbers are, right? Specifically, this eventually ends up negative, this is positive, right? Now, did you have to put a 10 on there? No. Could you have put a 47.28? Totally, I don't care. Because again, 47.28 is a bigger number than 9/2. Great. I don't care if you always want to pick your favorite number, right? If your favorite number in the whole world is pi is about a 3. So, hey, look, there's pi, right? Again, you don't have to worry about scaling your axes, or your number line rather, because literally I just need you to put 2 numbers. The number that you want, and whatever other number you want that gives me an idea that you understand the way the direction works, okay? If you're somebody who's like, hey, I'm stubbornly really hooked on this whole 0 thing, you could be like, hey, I'm always going to use 0. Now, eventually, when we start solving these in a couple more examples, there are going to be 2 numbers in our answer, and then both of those should appear on the number line. But that's really the short answer here. So now, when we talk about how to graph this, what we're saying is x is numbers greater than or equal to 9/2. So there are 2 ways to graph this, okay? One way to graph this is to put a closed dot at 9/2 and go up, because the closed dot is what tells us equal to, okay? An open dot would mean just strictly greater than, okay? Just greater than or less than. And then this arrow is saying that these are the answers I want, okay? So that's one way to do it. Another way you'll see this sometimes is with a bracket, okay? A bracket means equal to, okay? A bracket symbol. And I'll show you why that comes up sometimes, but mostly the short answer is it comes up because when you're typing stuff in a textbook, brackets are a really easy thing to get on a keyboard, right? And dots are more annoying. So again, notice that the closed dot and a bracket, okay, both of these things, they mean equal to, right? And an open dot or a parenthesis, both of those things would mean not equal to. So if we're just saying less than, okay? And we're gonna practice with that in a little bit. The third thing that we're going to talk about is what parenthetical notation is, and that kind of ties into these brackets and parentheses. So the way parenthetical notation works is parenthetical notation is not an ordered pair. Parenthetical notation is a way to write a solution by saying this is the first x value that would work, which in this case you can see this is my window where my answer is. My answer would be 9/2 or 4.5, right? And then the last x value, right, the final x value that would work, well, in this case, it goes up to infinity because these arrows go on forever. There's no final x value. And then because I'm including So remember, a bracket means equal to, right? So since I'm allowed to include 9/2, like 9/2 is greater than or equal to 9/2 would be a true statement. I'm going to put a bracket, but then I'm going to put a parenthesis at infinity because you can't reach infinity. So we're going to do some more practice with all of these skills a lot in this section, and you're going to see parenthetical notation for a really long time, but this would be the solution in what we call inequality notation, right? Inequality notation uses an inequality symbol. This would be a solution presented graphically, and it's either this one or this one. The other way you'll sometimes see it is with it physically drawn on the number line. I personally like to draw it above the number line instead of on the number line, just because it feels neater and cleaner to me, but all of these would be an acceptable way. You don't have to write all three of them. All of them would be fine. And then this is what we call parenthetical notation. So I'm going to walk through P1 in exactly the same way, and then you can pause me if you want to do it yourself, okay? So it's up to you. The first thing I would say that you might notice is that most of the time, so it is easier to graph if your variable is on the left-hand side. It's much easier to graph because here it says x is bigger than or equal to 9/2. Notice that the arrow points in the same way that my arrow goes. So that's a little bit easier. So one way to deal with P1 is, since your variable's already on the other side, you could either add add to the negative 3x by adding 3x to both sides, or you could just flip the whole thing. Remember, you're allowed to flip an entire inequality, right? But if you do that, you have to flip the direction of the arrow too. So I'm going to flip the whole thing. Now I'm going to go ahead and use subtraction and addition. Well, this is a positive 7, so I'm going to subtract the 7 over. So I'm going to get negative 3x is greater than a negative 11, right? And then I'm going to do division and multiplication. But remember, when we multiply or divide by a negative, we have to flip the inequality sign. So when I divide by a negative 3, I'm going to circle this, and that's my heads up that I need to flip this sign. I do that every time. I've done it every time for years, because that way I just know, hey, I'm not going to accidentally forget to flip the sign. So I get that x is less than 11/3. Now, if you had not done this whole thing, if you hadn't flipped it first, you might have done everything I did, and you would have gotten 11/3 is greater than x, and then you could have said, oh, hey, I'm going to flip that so that the x is on the left-hand side. It would come out the exact same way. It's absolutely fine. You could have solved it. You could have gone like this and done SADMAP, and you would have gotten exactly the same answer, but in the opposite order. It's just easier if your x is on the left-hand side when you're graphing, or your y, or whatever your variable is. So now, this is my solution, right? That's my solution. Now, if you want to write 11/3 as a decimal, you can. I'm going to say that a fraction is probably better, but if you would rather write this as 3.6 repeating, that's totally fine, because this is 3/3 and then 9/3 and 2/3, so it's 3 and 2/3, which is 3.6 repeating. Second thing I'm going to do is I'm going to graph it. Remember, the only number that needs to show up on my number line is that 11/3, and then put any other number you want. So I'm just going to put a 5 here, because I know 5 is bigger than that 3.6 repeating. Because this is not equal to, it's going to be an open circle, and because it's x values that are less than this, I'm going to shade to the left. I'm going to shade the lower x values. One easy way to see if this is right, because this represents the solution, one way to see it's right is try plugging in a number that is somewhere in this window and see if it works. 0 is less than 11/3. That's true, right? 0 is somewhere down here, right? So 0 is less than 11/3. Negative 20 is less than 11/3. That would be true, right? So that's my window. Again, the other way to write this would be a parenthesis. We write the parenthesis bending towards the shading that we draw, okay? And then, again, if you prefer, you could actually write it on the number line like this. I kind of prefer, this is sort of my default preference. P1 is that we're going to write this answer parenthetically. So if you notice, so parenthetical, think about parenthetical like the time interval, right? So you always want to start with the lower x value to the higher x value, because it's sort of like if I ask when you're in school and you tell me from 2:54 to 7:50, that's not right. You actually are in school from 7:50 in the morning to 2:54 in the afternoon, and if you list those two numbers in the wrong order, if you say 2:54 first and 7:50 second, you're implying that you're starting school at 2:54 and ending at 7:50, and that's not what you mean. So in parenthetical notation, there is an order of things, right? So when we want to write our answer parenthetically, we're going to write whatever the starting x is up until the ending x, right? Well, the starting x is negative infinity here, because that arrow goes forever, and I'm going to put a parenthesis for the same reason I did over here. You can't actually reach infinities. And then it's going to end at 11/3, right? That's the ending value, right? But I'm going to put a parenthesis because, again, you're not, so it's not equal to the 11 thirds, right? It's strictly less than 11 thirds. So what this says is all x's in the window from negative infinity to 11 thirds, but not including 11 thirds. So that excludes 11 thirds. So that's sort of the idea of how this works. So we're going to keep kind of plugging along. Like I said, we will do some of the ones that are in the book today, because some days the book examples are solid and some days I don't particularly think they are, or some days I'm super into the book examples and some days I'm not. I am asking you to do something the book example doesn't, which is I'm asking you to do parenthetical notation. So if we look at example 2, which will also use the book's example, again, remember I'm asking you to do 3 things. I'm asking you to solve, I'm asking you to graph, and I'm asking you for parenthetical notation, which the book does not. Right, so you're giving me both. So we'll do example 2, which is also on page 55 of the book. So we're going to solve, they did 4 minus 3p is greater than 16 minus p. And then we're going to do the same thing with a p2 that is right below that on the page, which will be 5 minus 7t is greater than 8 minus 4t. Okay, so I've already expressed that my significant preference is to put the variables on the left-hand side. Sooner or later, that's going to be easier in the problem, so I'm just going to start by making sure I move all the p's to the left-hand side. So I'm going to start with subtraction and addition and move all the p's to the left-hand side and the non-p's to the right-hand side. So on this side, I'm going to get negative 2p is greater than 12, right? When I do division and multiplication, notice that I'm dividing by a negative, which means I need to flip the direction of this sign. So I'm going to get p is less than negative 6, right? So, cool. So now a couple things going on here, right? So that's my answer. That's my solution, right? The second thing I need to do is graph this. Remember, the only number that has to show up on my graph is this negative 6. And then I pick any other number just to show I understand the direction that numbers go on a number line. So I'm just going to pick negative 5 up here, right? Because negative 6 is smaller than negative 5. Great. Because this doesn't have an equal to, it'll be an open circle, and I shade the values less than negative 6. And you can see that this would work because if I pick like a negative 7 is less than negative 6. Negative 200 is less than negative 6. Lastly, if I write this parenthetically, the starting x is a negative infinity, which always gets a parenthesis because you can't actually reach an infinity, and the ending x is a negative 6, which will also get a parenthesis here. Because again, you're not actually including negative 6, right? So I'm going to walk through the same skill set with P2. If you want to try it without me, go ahead and pause. All right, so I'm going to move all my t's to the left-hand side first. So I'm going to start with subtraction and addition, and I'm going to add the 4t to the left-hand side, and I'll subtract the 5 to move it to the right-hand side. So I'm going to get negative 3t is greater than 3. When I do my division and multiplication, notice that I'm dividing by a negative again. So I need to make sure that I circle that sign to switch the direction. So I'm going to get that t is less than negative 1. So that's my solution, right? When I graph my solution, the only number that has to show up on my number line is a negative 1. And then I pick some other number. I'm going to pick negative 10.8. Why? Because I can, right? You could pick whatever number you want. Notice that this is an open circle because it's not equal to, and that I'll shade numbers less than negative 1. Lastly, when I write my answer parenthetically, it should be negative infinity to negative 1, right? Because I'm starting at negative infinity all the way at the left, and I'm ending at negative 1, okay? So that's the gist of the first couple of examples. We're going to start doing some slightly harder problems at this in the next video.